Bismillahirrahmanirrahim. Assalamualaikum dan salam sejahtera. Bersama saya pada minggu ini, Medium Unknown. Untuk program Lepton dan Meka. Chapter 5, Work and Energy. Untuk Fizik di 014. So minggu ni kita akan buat satu kelainan sikit, di mana kita akan discuss soalan berbentuk objektif sebagai persediaan untuk menghadapi UPS 3 nanti. Jom bersama-sama saya. So ini contoh soalan dan nanti medium akan letakkan di ruangan description, so pelajar boleh mencubalah. Contoh saya sekarang adalah sebagai pelajar. Saya masukkan nama. Contoh ya. Seterusnya matric number, pilihlah kamu punya program. Seterusnya pilihlah kelas praktikum. Baiklah, next. Right, so dia akan bawalah kepada soalan berkaitan dengan chapter 5 Work and Energy. Jom kita tengok soalan satu. Ada satu tempat kosong. Is done when a force N cause an object to move a certain distance m. Apakah pilihan jawapan yang sesuai? So di sini jawapan yang sesuai adalah work. So work is done when a force, unit Newton, cause an object to move a certain distance m. Next, question 2. Which of the following is the best example of work is being done? The work is being done. Maksudnya cikgu ada satu nilai work done. Doing homework, bukan konsep fizik di sini. Lifting a box, maybe. Number 2. Pushing a stationary box. And then holding a box. Cikgu cuba dapatkan jawapan. Contoh di sini. Right, so cikgu nak dapatkan idea. So sewaktu saya cuba menjawab soalan UPS 3 kelak, pastikan saya ada pen dan pensel lah. Contoh kat sini cikgu mulakan W equals to Fs cos theta. W equals to Fs cos theta. So soalan dia nak which is the best example of work being done. So kalau saya lifting a box. Lifting a box. Saya angkat box saya ke atas. Lifting a box. Apa yang berlaku kalau saya angkat box ke atas? Box cikgu akan naik ke atas. So sekarang untuk case ini, angle between force and displacement is 0 degree. So cos 0 degree equals to 1. So, and when we lifting a box, work is being done. So, saya cubalah pilih answer number 2. B. Right, so kalau yang number 3 ni, pushing a stationary box. Dia cuba push, dia cuba push, tapi dalam kes ni, objek itu kekal stationary. So kalau dia kekal stationary, apa yang berlaku? So V equals to 0. V equals to 0. Macam mana dengan dia punya F net? First cikgu letaklah dulu. V equals to 0. A equals to 0. So how about F net? F equals to MA A0. So answer saya F net is equals to 0. So saya akan dapat work done. So kalau F ni 0, so work done cikgu akan nilai 0. Kan? Sebab W equals to Fs cos theta. So kalau F nya 0, work done 0. So kita pergi kepada question 3. Okay, we go to question 3. Work is done on an object when the object moves in the same direction in which the force is applied. Okay, is it true? Yes. Okay, when the work is done on object, the object move in the same direction as the force is applied. Kalau cikgu tolak box saya ke kanan, so box itu akan bergerak ke kanan, so same direction, so true. Okay, choose true. Okay, next, describe the work done in the picture if the porter move forward onto a train with the luggage. Answer kat sini, mana satu? Okay, force-nya ke atas, cikgu tarik. Okay, yang case ni, cikgu angkat box tu ke atas. Okay, the box is lifting upward, but the porter is moved forward. So angle between, so cuba try kita sketching sikit. Okay, the angle between force and displacement. Okay, try to sketching. Lifting force is upward and the porter move forward, so displacement forward, force upward, so angle between force and displacement, W equals to Fs cos 90 degree. So the answer will be 0. So means our answer is the first one. There will be no work done. Okay. And before that, unit for work is joule. Don't forget, unit for work done. Okay, we go to the next question. Okay, fill in the blank. Is the ability to cause the change. Which one? Energy, friction, force, motion. Okay, energy. Yes, the answer is A. Energy is the ability to cause the change. Kalau saya tak ada tenaga, saya tak buat kerja lah. Okay, kan kita biasa guna gitu kan. Okay, so energy is the ability to cause the change. Energy cannot be destroyed, but can be changed to the other form of energy. Next, okay, energy due to motion is the ... And what type of energy? Due to motion. Which one? Okay, right. So, sorry. Okay, so kita check. Maybe, okay, maybe potential energy, maybe kinetic energy. Okay, so we try to write the equation for potential energy. Ug, okay, Ug equals to mgh. So potential energy depend on height or position. Okay, Ke, kinetic energy, Ke equals to half mv squared. Kinetic energy depend on velocity, or kinetic energy depend on motion. So answer is kinetic energy. Okay, energy due to motion is kinetic energy. Next, gravitational potential energy depend on the blank and blank of the object. Okay, now gravitational potential energy refer to this question. Ug equals to mgh. So potential energy depend on mass, depend on gravity, depend on h. Okay, so we look at answer A. Okay, depend on the height and mass. Yes, that's the answer. Okay, depend on mass and height. Okay, next question. When you stretch a rubber band, you are storing Which one? Gravitational, kinetic, elastic potential energy. The answer will be, okay, so here rubber band. Rubber band is an elastic material. So when we stretch a rubber band, stretch here refer to the stretching value. Okay, so stretch. So, okay, saya cuba tambah lagi satu equation dalam saya punya sticky note ni. Okay, so US equals to half K X square. Okay, K spring constant. Okay, X here adalah stretching or compression. So, ada value berkaitan dengan stretching. So, maksudnya kat soalan ni, when you stretch a rubber band, you are storing. The answer is elastic potential energy. Okay, next. Okay, for some spring, the amount of force is directly proportional to the amount of stretch or compression. The constant of proportionality is known as the string constant. Okay, describe which law? Okay, describe which law? According to this sentence, okay, the force is directly proportional to the amount of stretch or compression. Okay, let's get F directly proportional to the amount of stretch or compress. Okay, the constant of proportionality is known as the spring constant. Okay, so selain daripada relationship ni, okay, cikgu boleh tulis F equals to negative Kx. So F equals to negative Kx is Hooke's law. Okay, is Hooke's law. Okay, next. Energy cannot be created or destroyed, only converted from one form to another form of energy. So is it true? Yes. Energy cannot be created or destroyed. It only converted from one form to another. Okay, itulah. Okay, next we go to the next question. At which point the potential energy is greatest? The potential energy is greatest. Potential energy depend on height. Jadi kita cari mana satu tinggi yang paling, okay, which one H greater? At position W, at position X, at position Y, at position Z. So you compare which one H is higher. So the answer is W. The answer is W. Paling tinggi kan? Di W. Okay, yang paling maksimum di W. Okay, next. As a pendulum swing from highest to lowest position, what happened to its kinetic energy and potential energy? What happened? Okay, highest to lowest. Okay, kita check dulu kinetic potential energy. UG equals to mgh. Highest. Okay, highest H, apa nak buat, H max to H minimum. So what happened to UG? Increase or decrease? Height to minimum. So our H will be decreasing. So my potential energy, so gravitational potential energy for pendulum is being decreasing. How about the kinetic energy? Okay, at highest position, the potential energy is maximum. So potential at highest position, at H max, okay, at H max, UG is max. Okay, UG is max. Okay, so at maximum height, velocity is equals to 0. So kinetic energy also 0 joule. Okay, from highest position to the lowest position, what happened? The velocity is increasing. So kinetic energy of the pendulum is also increased. Okay, from the highest position to the lowest position. Okay, so which is the answer? What happened to its kinetic energy and potential energy? So, okay, just look at first answer. Both potential and kinetic energy, both potential and kinetic energy decrease. No. Okay, the potential energy decrease while the kinetic energy is increase. Yes. So kita refer pada sticky note. Potential decrease, kinetic increase. Okay, potential decrease, kinetic increase. So itulah jawapannya. Okay, kalau yang ni, the third one, the kinetic energy decrease, potential increase. Balik. Okay, both the potential energy and kinetic energy increase. Pun salah. Okay, answer second one. The potential energy decrease, kinetic energy increase. From the highest to the lowest position. Okay, next question. At which point is the kinetic energy greatest? Kat mana? Okay, so kinetic energy depend on motion. Okay, so kalau dekat position X, position W, potential maximum kinetic 0. Okay, ataupun potential maximum kinetic minimum. Going downwards, velocity increase, so at the lowest point X, the kinetic energy will be greatest. Okay, so the answer is X. Okay, next question. When the pendulum swing, at which point the kinetic energy is highest? Samalah dengan konsep tadi. Okay, kinetic energy highest at the lowest point. So at position 1, 2, 3, 4, 5. So which is the lowest point? The lowest point is at the point 3. So answer 3. So at point 3, kinetic is highest. Okay. When the pendulum swing, at which point is the potential energy is greatest? Potential energy greatest at the maximum height. So we have 4 answer here, position 1, 2 or 3. So the answer is position 1. Okay. At the position 1, the pendulum swing. At the position 1, the pendulum has the greatest potential energy. So that's all. So we submit. Okay, look at our score. Okay. Yes, we get full mark. So that's all for our discussion for today. Okay, best of luck for UPS 3. Thank you.